Assalamualaikum warahmatullahi wabarakatuh and greetings to all students. I hope you have go through my notes that I have given to you before so that our discussion today will be smooth and fast, right? Okay, for this lecture, actually, we have 4 learning objectives or learning outcomes, but the learning outcomes is very simple because some of them are just memorizing, not understanding the concept, right? So we look one by one through the question given to you after this, okay? So the first learning outcomes that you want to achieve in this lecture is to explain the physical properties and compare the boiling point and also the solubility of the alkenes, right? The second, state the natural sources of the alkene. So this is just you need to just memorize. So what are the natural sources of the alkenes? Number 3, describe the combustion of alkenes in excess and also limited oxygen. So you need to know how to write the reaction equation for the combustion of the alkenes, okay, in both conditions. And the last one is to explain the unreactivity of the alkenes. Alright, so let's go for the first question. Rank each of the alkenes in order of increasing boiling point. Explain your choice of order. So dekat sini you can see that there are two situations. For the first question, there are different length of the alkenes. Okay, but for the second question, the alkenes have the same molecular formula. Alright, so how to describe the boiling point of these alkenes? Okay, we go for the first question, which is different length of the alkene. So the first point, you need to find the similarities. So the similarity between all these three compounds are, they are linear alkane. Therefore, they are all have only van der Waals forces. Alright. So what are the different? They have different number of carbon and hence different length of the main chain of the alkene. Okay, so the point number 1, they have different number of carbon. So the more number of carbon, okay, the more number of carbon, therefore the surface area of the alkene will be larger. Okay, surface area of the alkene will be larger. So what is the effect of the larger surface area? They have more van der Waals forces, right? So what is the effect of the more van der Waals forces? We need more energy to overcome the van der Waals forces to separate the molecules of alkene. So more energy needed. And point number 4, when more energy needed, we can conclude that the boiling point of the alkenes are higher. Okay, so this is the arrangement from the propane to butane to pentane. Okay, so dalam ayat dia macam ni lah ayat dia. Alright. Okay, the compounds are linear alkanes with different number of carbons. As the number of carbon atom increase, the molecular size and the surface area increases. Okay, thus the van der Waals forces become stronger and more energy needed to overcome the forces results in higher boiling point. So ni ayat standard, nak faham yang point-point yang saya bagi tadi. Alright. Okay, next. Okay, so sama juga. The first thing you need to find the similarity. Okay, so all these alkanes are isomers. Okay, isomers with the molecular formula C6H14. Okay, C6H14. So what are the difference between all these isomers is the number of branching. Okay, number of branching. So we see what is the effect of the branches. Okay, number one, more branching or more branches, the surface area will be smaller. Okay, and then you just follow the point same as the previous question. Okay, when the surface area is smaller, so less van der Waals forces that combines or interacts between the molecule. Okay. Point number 3, when you have less van der Waals forces, therefore you need less energy to overcome the forces. And the conclusion, number 4, when you have less energy needed, so the boiling point will be low. Alright, so dalam bentuk ayat dia adalah like this. Okay, the compounds are alkanes with the same molecular formula C6H14 but different arrangement of the carbon atoms. So they are all isomers. Okay, as the number of branches increase, the molecule become more compact and the surface area decrease. Thus, the van der Waals forces attraction between the molecules, or less van der Waals forces attraction between the molecule, and hence less energy needed to overcome the forces, result in lower boiling point. Alright, so just as simple. Okay, so let's go for the next objective. State the observation when pentane meets with the following solvent. Okay, so we need to know that pentane or an alkane. Okay, pentane is an alkane. Alkanes are hydrophobic compound. Okay, hydrophobic compound. Dia juga bersifat non-polar. Okay, non-polar. Kalau dia hydrophobic, mean that dia tak suka air. Hydro is water, phobic tu phobia lah. Okay, dia phobia dengan air. Dia tak suka air. Okay, therefore, pentane do not mix with water. Okay, dia tak boleh mix with water. And alkanes is a non-polar molecule, so that dia akan mix with also non-polar molecule. For example, toluene and tetrachloromethane. Okay, tetrachloromethane. And when it mix together, okay, bila dia mix, dia akan jadi homogeneous mixture. Okay, yang tak mix ni, okay, dia akan jadi heterogeneous mixture. Alright. Malah, the alkanes itself can be a good solvent, but must be a liquid alkane lah. Okay, contoh macam pentane ni sendiri. Okay, the pentane is a type of a liquid alkane, so dia sendiri boleh jadi a good solvent, a good non-polar solvent. Alright, so dalam bentuk ayat dia macam mana? Okay, number 1, toluene. Okay, pentane miscible. Kita gunakan perkataan miscible for the solubility of the liquid in the liquid. Okay, liquid dalam liquid kita guna perkataan miscible. Okay, so pentane miscible in toluene and form homogeneous mixture. Number 2, pentane immiscible. Dia tak bercampur. Okay, in water and form heterogeneous mixture. And number 3, pentane miscible in tetrachloromethane and form homogeneous mixture. Alright, next question. The major sources of the alkanes are from the fossil fuels. Okay, list 3 types of the fossil fuels. Okay, yang ni dah ada dalam lecture notes pun. Alright, so I just mention again and again. Okay, so the first one is the natural gases, second is the crude oil, and the third one is the coal. So ini dalam fasa gas, ini dalam fasa liquid, and this one in the solid state. Alright, so kenapa ini gas? Because the compound is very short. Okay, so dia punya van der Waals forces dia tu tak berapa banyak, so the molecule boleh, the particle of the molecule boleh randomly lagi bergerak ke sana sini lah. Alright, that's why dia dalam fasa gas. Okay, yang ni dia dah panjang sikit, C5 to C18. Okay, so dia semakin mendekati antara satu sama lain, the van der Waals forces become stronger than the previous natural gas, so it's become a liquid, which is the crude oil. Okay, and lastly, bila dah terlampau panjang sangat dia punya rantai, which is C19 and above, dia akan jadi sangat-sangat kuat dia punya van der Waals forces, molekul pun akan merapati antara satu sama lain, menyebabkan dia jadi dalam fasa solid. Alright, okay, next. Write the reaction equation for 2,2,4 trimethyl burns in excess and limited oxygen. Okay, so yang ni nak tulis dia punya equation. Actually, the structure of the molecule is not that important, but we need to draw the structure of the molecule in order to know the molecular formula of that molecule. So 2,2,4 trimethyl pentane. So mula-mula kita lukis dulu pentane tu. Okay, 1, 2, 3, 4, 5. At the carbon number 2, we have 2 methyl. So at the carbon number 2, we have 2 methyl, 1 methyl, and 2 methyl. At the carbon number 4, we have another methyl. So this is 2,2,4 trimethyl pentane. So kalau kita tukar ni dalam bentuk condensed formula, so sini adalah CH3. Okay, CH3. Yang ini adalah C sahaja. Okay, dan atas bawah dia ada methyl group. Okay, CH3. This one is the CH2. Okay, CH2. This one adalah CH. Okay, only CH. Dan atas dia adalah methyl group. Okay, CH3. And hujung dia juga adalah CH3. Okay, so daripada sini kita boleh kira dah dia punya bilangan karbon ada berapa. 1, 2, 3, 4, 5, 6, 7, 8. So C8. Alright, and dia punya hydrogen ada 9, 10, 16, 18. C8H18. Dan ini bertepatan dengan general formula of the alkane, which is CnH2n plus 2. So C8H8, 2n is means 8 times 2 is 16 plus 2 is 18. Okay, so dah betul lah ni. Okay, dah betul dah kita punya penentuan molecular formula. Okay, next. Daripada molecular formula kita tindak balaskan dengan oksigen. So C8H18 tindak balas dengan oksigen in the presence of heat menghasilkan carbon dioxide and water. Okay, always for the combustion of the hydrocarbon produce carbon dioxide and water. Okay, so macam mana kita nak balance this equation? First kita tengok pada C. Okay, mula-mula kita tengok pada C ada 8. So we put 8 for the carbon dioxide. Okay, yang kedua kita tengok pada H. Okay, kita ada 18 of the hydrogen atom. So 18 divide by 2 means 9. So kita kena letakkan 9 water molecule. Okay, and then barulah kita kira the number of the oxygen. So kat sini ada 8 times 2 is 16 oxygen. Kat sini 9 oxygen. So kita total ni akan jadi 25. So 25 over 2. Ataupun you boleh darab all this equation by 2. So you dapat 2C8H18. Okay, plus 25 O2 produce 16 CO2 plus 18 H2O. Okay, So the same concept you can use for the limited oxygen. Okay, limited oxygen, you just tukar this CO2 kepada CO sahaja. Okay, so the number over here 8 and 9 masih lagi tak terjejas because we just remove the O, bukannya kita remove C or H. Okay, so 8 and 9 masih lagi kekal, but the difference is the number of the oxygen. So sini 8, okay, 8, sini 9, so total is berapa tu? 8 campur 9 is 17. So 17 over 2. Okay, 17 over 2. So darab 2 untuk keseluruhan. Persamaan jadilah 2C8H18 plus berapa tadi? 17 O2 produce 16 CO sahaja kan, plus 18 H2O. Sama juga kalau dia punya oxygen is very limited. So dia tak hasilkan CO pun. Dia hasilkan just a carbon. Okay, dia hasilkan just a carbon. Saya nak guna warna apa pula? Orange pula. Okay. Still, 8 dengan 9 tak berubah dia punya nilai. But the number of oxygen is different. Which is, sekarang ni the number of oxygen is only 9. So jadi 9 over 2. Okay. Ataupun kalau kita darab 2, so kat sini akan jadi 9. Alright. So ni yang saya conteng-conteng. So kita tengoklah persamaan yang saya dah tulis dalam menggunakan PowerPoint ni. So dia cantik sikit lah, kemas sikit. Okay. Betul kan yang kita buat tadi? Okay, this the equation in excess oxygen, and these two are the equation in limited oxygen, 17 and 9. Okay, yang ni tadi 25. Okay, yang belakang ni tak berubah. 16 sama. Okay, 18 is the same. Okay, 2 is the same. Okay, nombor tu tak berubah. The difference is just oxygen. Sebab yang ni oxygen berkurangan. Yang ni oxygen banyak, 25. Okay, yang ni dah berkurangan. Yang ni lagi sikit oxygen. Alright. Okay, next. The last question. Alkanes are inert compounds and unreactive to most reactions. Explain the unreactivity of alkanes. Ini juga soalan yang berbentuk hafalan, yang you kena hafal. Okay, saya dah bagi pun dalam lecture notes. So ada berapa yang saya bagi dalam lecture notes tu? Ada 4 kan? Okay, so the first one, dia hanya mempunyai single bond. Maksudnya apa kalau dia mempunyai single bond? Maksudnya dia adalah saturated hydrocarbon. Okay, saturated maksudnya dia tidak boleh mengalami tindak balas penambahan, addition reaction. Kalau dia ada double bond, dia boleh masuk something which is electrophile, kita boleh tambahkan kepada that compound. Tapi alkane dia tak ada double bond, tak ada triple bond, dia hanya single bond. So dia saturated, tidak boleh mengalami tindak balas penambahan or addition reaction. Okay, so jadi dia tak reaktif lah. Okay. Number 2, sebab dia stable CC and CH bond. Kenapa CC and CH bond ni stable? Because CC and CH bond adalah sejenis ikatan covalent. Okay, and kita tahu ikatan covalent adalah satu ikatan yang sangat kuat, seperti mana ikatan ionik dan juga metalik. Malah boleh dikatakan covalent adalah lebih kuat berbanding ionik dan metalik. Okay, so that's why dia sangat stable. So ikatan CC dan CH ni sukar untuk diputuskan, maka dia susah untuk berlaku tindak balas. Okay, yang ketiga, C and H similar electronegativities. Maksudnya apa kalau dia mempunyai similar electronegativities? Maksudnya dia adalah non-polar. Right? Dia adalah non-polar molecule. Okay, so non-polar dia tak reaktif lah. Okay, yang polar tu yang senang berlaku tindak balas. Right? And the last one, dia no functional group for sure lah kan. Ini adalah first homologous series of the organic compound. Memang dia tak ada functional group apa-apa lah. Okay, bila masuk saja alkene nanti barulah ada functional group. Dia ada double bond. Okay, tajuk lain-lain semua ada functional group. Ini sahaja yang tak ada functional group. Alright. So that's all for this lecture. Just a simple lecture. Okay, I hope you can study about this. Okay. See you in the next lecture. Thank you.